In this video, we're going to look at solving equations that are in quadratic form. So let's remember what a general quadratic equation looks like. It's going to be in this general form right here, ax squared plus bx plus c equals 0, or it can be put into that form. So the a, b, and c here are going to represent the coefficients, some numbers, and then you've got your variable squared, and then just your variable here, and then you may or may not have some term that doesn't have a variable. Now this is a typical example that you're going to see as an equation in quadratic form. We're going to solve it a little bit differently than the other ones. I'm going to go through about 4 examples here. This one is pretty straightforward. You can just approach it from a factoring standpoint. You always kind of want to look at that first and say, could I just factor this? So if you only have a coefficient of 1 here, so you can ask yourself, is there something that multiplies to be 36 and adds to be negative 37? So this is a pretty simple factoring problem. In other words, if you think of it as an x squared minus 37x plus 36 and just factor it, you would say, well, 36 times 1 is positive 36, but I need a negative 37 in the middle. And then x times x is x squared. All right, so the only difference over here is, we're still going to have this, that we need these first two terms in the parentheses to multiply to be y to the 4th. So that's going to be y squared times y squared. And if you FOIL this out, you'll see that you do get negative 37y squared in the middle, because you're going to end up multiplying y squared times negative 36 and negative 1 times y squared, and add those together, and that'll give you your negative 37y squared in the middle. So now you can use the property that you use when two things multiply together to equal 0, zero product property. Either this one has to be 0, this first factor, or this second factor would have to be 0. Alright, so now we have another factoring problem, y squared minus 1 equals 0. You could factor it, or you could use the square root property. Let me do one way and one the other way so you can see them both. So this is the difference of squares. So that's going to factor to y minus 1, y plus 1. So then y minus 1 is 0, or y plus 1 is 0. And that would give us y equals 1 and y equals negative 1. Now the other way to do it, since you don't have a y term, is, and I'll do it here on this y squared minus 36, you could add the 36 over. So like on this one, we could have added the 1 over. And that would give you y squared equals 36. And then take the square root of both sides. And that gives you y equals plus or minus 6. Which would have been the same thing you would have gotten if you would have factored it to y minus 6, y plus 6. Okay, so your final solution set, y equals positive or negative 1, positive or negative 6. There's actually 4 values of y that make this true. And that's typical. If you have your highest exponent there as 4, you could have up to 4 answers. You're not going to have more than 4, and it's not always going to be 4 unique answers, but there's a possibility that you could have up to 4 answers. Okay, so that's pretty straightforward. It's a little different because of the y to the 4th, but it's the same idea, factoring and setting equal to 0. You just might have to do it again down here. All right, let's look at a little different example, one that's a little more complicated, I think. Let's say we have the quantity y minus 4 squared plus y minus 4. I'm going to put that in parentheses, minus 20 equals 0. Now, one thing you could do to solve this is you could FOIL all this out and then combine like terms and see what you have left. But there's a little method here that we're going to use. And I'm going to pull this in. Now we have our general form ax squared plus bx plus c equals 0. But if we look at an equation that we could kind of put in quadratic form, what we're really looking for, instead of maybe just a variable x, we could have some kind of glob, something squared. So we have a number times something squared plus b times that same something. It's got to be the same glob. Do you see what our glob is in this problem here? All right, let's see if we can figure it out. Our a value here is 1. We've got like a 1 here. 1, here's your glob squared plus, and your b value is 1. Here's this same glob again, minus 20 equals 0. So what you want to do is you want to do a substitution. When you figure out what that glob is, and that's the most important part, then you're going to make a substitution with a different variable. Let's say u. So you let u equal the glob. That's what you want to do. So in this case right here, our glob is y minus 4. So we're going to say let u equal y minus 4. Now we're going to substitute u where the y minus 4 was. So what do we get? Instead of y minus 4 squared, we get u squared. Plus, and then instead of y minus 4, we get u. And then we still have the minus 20 equals 0. So with that little substitution now, we've created a pretty straightforward quadratic problem we can solve, equation we can solve. Again, we can solve this one by factoring. We don't have to pull out the quadratic formula because there is something that multiplies to be negative 20 and adds to be 1, which would be positive 5 and a negative 4. Again, these are easier to factor because you just have a coefficient of 1. If there wasn't a coefficient of 1 here, you'd have to approach it a little bit differently. Oops, my u got out of control. There you go, u. Okay, so let's finish solving this and figure out what u is. So u minus 4 equals 0, which means u could be 4. Or, why am I doing that? I want to make a y. Or u plus 5 equals 0, which means u is negative 5. All right, well, that's great. Now we know what u is, but we want to know what y is. Remember, in the original equation, we have y's. It's nice to know what u is, but we're not done. So what we have to do is take this substitution that we did right here. We know u equals y minus 4. So we need to plug in our values of u to figure out what y is. So let's start with this one. We know that u equals 4. So we just come up here and we put 4 where that u is. So we get 4 equals y minus 4. Now we can solve that. Just add 4 to both sides and we get y equals 8. So there's one of our answers. Y equals 8. Do the same thing. Take the negative 5 and put it in for u. So our original substitution formula there. Take that guy, put him where the u is. Let's see what we get. Negative 5 equals y minus 4. Add 4 to both sides. We get negative 1. So there's our two answers. All right, so that's the general strategy. We're going to do a couple more here, but that's the general strategy. You got to figure out what your u is, which is going to represent your glob. Substitute that u in, solve it out. It should make an easier problem for you once you do the substitution. Solve it out, figure out what u is, but then you got to put u back in to whatever little substitution that you made, okay? And then you'll have your answers. Let's try another one. The thing with these, I think that's helpful is seeing bunches of different examples, and you'll start to recognize it because it's really a pattern thing. You're looking for certain patterns. All right, let's look at this one. 3 minus 7 over 2x plus 2 equals 6 over the quantity 2x plus 2 squared. All right, a little weird looking, but can you kind of see what your glob, you're going to have your glob and then you're going to have your glob squared. So you're looking for something and then that something appears in the equation somewhere else and it's squared. Well, it looks like it's right here, right? Okay, now this one here, this looks like it could be the glob, right? 2x plus 2 and 2x plus 2 squared. But it is in the denominator, okay? So it can't be in the denominator. It's got to be, we don't want to put u's in the denominator down here. So let's think of it like this. Let's see. Since it is in the denominator, I could really just think of it as 1 over 2x plus 2. Actually, let me put the 7 first. So it's more in the right form. 3 minus 7 times. Okay? So 1 over 2x plus 2 could be my glob. And this could be 6 times the quantity 1 over 2x plus 2 squared. All right, so there's your glob. Now, another thing, it's not set equal to 0, right? We need to get it in this form. So I need to set it equal to 0, move stuff around. Let's see, I can either take this whole thing and subtract it over here, or move these two things to the right-hand side. I think I'll move stuff to the right-hand side. So I'm going to have my 6, and it doesn't matter. It'll come out either way. Okay, so then let's add this whole 7 times my glob, 1 over 2x plus 2, and then subtract the 3 over. Alright, so now you can really see it, hopefully, this glob squared. So we know we want our u value to be 1 over 2x plus 2. So we're going to put a u right in there where that glob is. So now we're going to have 0 equals 6u squared plus 7u minus 3. Alright, so now we have to solve this and figure out what u is. And let's see, will this factor? To figure out whether it'll factor, and I'm going to use the AC method here. And if you're not familiar with that, there's a video on that. So you take the a value and the c value, you multiply them together, which is 6 times negative 3, that's negative 18. And then I got to figure out if there's anything that multiplies to be negative 18 and adds to be 7. And I'm thinking 9 and negative 2, or negative 2 and 9. What do you think? I think that'll do it. So then you take the middle term, the 7u, and you're going to split it up. So the first term's going to stay the same. The 7u is going to get split up to negative 2u plus 9u, and then we'll have our minus 3. I'm going to have to erase this stuff here. So we got to finish factoring this. Okay, so now we do factor by grouping. So we're going to group the first two and the last two, pull out a common factor. So the first set of parentheses has a common factor of 2u, which gives us 3u minus 1. And the second has a common factor of 3, which gives us 3u minus 1. So then we can take out the 3u minus 1. And when you're doing factor by grouping, remember, you know you're on the right track if these two parentheses come out to be the same. So once we take that out, then we have 2u plus 3. Alright, so 3u minus 1 equals 0, or 2u plus 3 equals 0. So if I add the 1 over and then divide by 3, I get 1/3. If I subtract the 3 over and then divide by 2, I get negative 3 over 2. Wow, this is a long one. Okay. So we have our u values, but remember, we're supposed to be solving for x. So we have to go up here and figure out what the value of x is. And we're going to use our substitution formula right here. Okay, we know u is equal to 1 over 2x plus 2. So we need to put these values of u in here one at a time and solve again. It's kind of a long process, huh? I'm going to get rid of this here so we have some room. So we take our formula, u equals 1 over 2x plus 2, and then we plug these two values in one at a time. So we'll have 1/3 equals 1 over 2x plus 2, and we'll have negative 3 over 2 equals 1 over 2x plus 2, and then we need to solve those, and we'll have our x values. So let's see, I think I'm going to use, there's lots of different ways to solve this, but there's a property of proportions. When you have a fraction equal to a fraction, you can flip them both over. So if two fractions are equal, their reciprocals are equal. So if I flip over the left-hand side, I get 3. And if I flip over the right-hand side, I get 2x plus 2 over 1, which is just 2x plus 2. So why did I want to do that? Well, my variable's in the denominator, so it's tough to solve for. I want my variable out of the denominator. So if I flip it over, it gets out of the denominator, then I got to flip this side. Kind of a little trick. Alright, so minus 2 from both sides, we get 1 equals 2x. Divide by 2, we get x equals 1/2. I'm going to do the same thing on this side. I'm going to flip this guy over and flip this over. Oops, that's a plus. That'd be sad to make a little mistake like that after all this, huh? So minus 2 from both sides. I get negative 2 2/3 equals 2x. Then I got to divide by 2 or multiply by a half. Since I'm dealing with a fraction, I guess I'll multiply by a half. So I have to turn this into an improper fraction, which would be 6 7/8 thirds. 6 7/8, yep. So that gives me negative 8/6. I guess I could reduce this down. Negative 4/3. I'll write it over here. All right. Wow, that was quite a process. So x equals 1/2 and x equals negative 4/3. That's your answer. So, you know, a lot of these concepts are not super complicated. It's just really calling on a lot of past knowledge and a lot of steps. I think the new part, and maybe the toughest part, is getting it in a form where you can figure out what that glob is, where we figured out that we want our u value to be 1 over 2x plus 2. Then it's just a lot of substitution, and you've probably done this factoring before and setting these equal to 0 and substituting and solving equations. It's a long process, but the key is figuring out what that glob is. All right, let's look at one more example. This example is not quite as long as the one we just did. And this is a common problem that you're going to see. All right, x to the 2/3 minus 2x to the 1/3 minus 3 equals 0. So already that looks a little bit less complicated than the last one we did. It's already set equal to 0. You can kind of see it's sort of in this form, but what is the glob? All right, well, we want our glob to be squared, and that's what this 2 is going to represent for us here. And then the next part, we want our glob to the first power, which is this. So it's the 3 in this denominator that's a little odd. All right, so let's look at it this way. I want something squared. I want my glob squared. And then I've got that 2 there. And my glob minus 3 equals 0. Well, a little hint. Since this glob in the middle term is going to be to the first power, whatever is right here in this middle term, whatever you think kind of looks like it could be the thing that's going to get squared over here, that's probably going to be your glob. All right, so let's do this in a different color. If I just leave this as x to the 1/3, notice if I put x to the 1/3 right here, if I take x to the 1/3 and square it, you just multiply these exponents and you end up with 2/3. So x to the 1/3 squared is x to the 2/3. So you see your glob there? Your glob is x to the 1/3. So we're going to let u equal x to the 1/3. So when you see these fractional exponents, there's probably going to be a 2 in the numerator and a 1 in the numerator, and then whatever this bottom denominator is, that's probably going to be your fractional exponent glob thing. That's kind of a pattern that is common. All right, if you want to, you could pause the video here and see if you can finish this one on your own. All right, so let's put u in for x to the 1/3. So we get u squared minus 2u minus 3 equals 0. This one is a nice, lovely, easy factoring problem. What multiplies to be negative 3 and adds to be negative 2 would be negative 3 and positive 1. So u equals 3 or u equals negative 1. So let's put those up here. U is 3, u is negative 1, and we got to use this relationship here and substitute back and figure out what x is. So u equals x to the 1/3, so 3 equals x to the 1/3, or negative 1. I guess I should say and. Negative 1. No, I should say or. Either or, right? They're both solutions. Okay, so to solve this, when you have x to the 1/3, you want this to just be an x. So what you want to do is you want to raise it to the 3rd power. Since I raised that side to the 3rd power, I have to raise that side. Same thing over here. We're going to raise both sides to the 3rd power. So 3 to the 3rd power is 27. And then notice how 1/3 times 3 is 1. So you just end up with x to the 1st. Negative 1 to the 3rd power is negative 1. And same thing here. So there's your answers. X is 27 and x is negative 1. And if you do plug those back in, you will see that it does solve the equation. You can always do that with any problem, is plug it back in and check it and make sure that it works. Well, I hope that helped you recognize this pattern. And that's really the part that that gets you going. You know, you got to figure out what this pattern is, what is going to be your glob. Once you figure that out, it's pretty much substitution and using skills that you've learned before.